Somewhere in Siberia, there is a tree that was alive when the Vikings sailed to America. It has survived 1,000 winters at minus 60 degrees. And every autumn, it produces a tiny nut that contains a molecule found almost nowhere else on Earth. A molecule that does something remarkable to your body. This is the story of that nut. Russians call this tree cedar, but it's not a cedar at all. True cedars grow in Lebanon and the Atlas Mountains. This is Pinus siberica, the Siberian stone pine. The name stuck so firmly that 87 Russian organizations carry it in their title. It grows up to 40 meters tall, lives for 400 to 850 years. The oldest recorded specimen was over 1,000 years old, and it thrives in temperatures that would kill almost any other tree on Earth. The Siberian pine has a partner. The Eurasian nutcracker carries an average of 142 seeds per trip in a pouch under its tongue. It buries them in thousands of caches across the forest floor, and the seeds it forgets become the next generation of 1,000-year-old trees. This is an obligate relationship. The pine nut is wingless. It cannot spread by wind. Without the nutcracker, the tree cannot reproduce. Without the tree, the bird has no food. They've been doing this dance for millions of years. For the Khanty, Mansi, Evenki, Buryat, and Altai peoples, the Siberian pine is the father of the forest, a guardian spirit. Before harvesting, prayers of respect are offered to the tree. The nuts aren't just food, they're medicine, currency, and connection to the land. Pine nut milk, kerovoi molocho, has been a breast milk substitute for centuries. 4 distinct preparation methods have been documented from elderly residents across 10 villages in Irkutsk, Transbaikal, and Buryatia. Women who learned them from their grandmothers. The Siberian pine is the keystone species of the dark taiga. These forests stretch across 23 million hectares, an area larger than the United Kingdom. Russia holds 23% of the planet's total forest area. These forests store 620 million tons of carbon. They're not just producing food. They're holding the climate together, but they're disappearing. 64 million hectares of Russian tree cover lost in less than 2 decades. Every September, pine nut fever grips the Altai Mountains. Families head into the forest for weeks at a time. The traditional tool is the kolo, a heavy mallet swung against the trunk to shake cones loose. It's dangerous work. A 43-year-old harvester died from a fall in Primorsky Krai. A 20-year-old survived with multiple injuries in Krasnoyarsk. The cold, the animals, the unsecured terrain. This is not a gentle profession. A team of 4 can collect 20 to 30 bags a day. The harvester gets about 300 rubles per kilo, roughly $3. By the time those same nuts reach a shop in Moscow or Berlin, they cost 2,000 rubles per kilo, 7 times the markup. The forest does the work. The middlemen take the profit. The harvesters aren't alone in the forest. Siberian brown bears need 20,000 calories a day during autumn hyperphagia, the feeding frenzy before hibernation. Pine nuts are a critical part of that diet. Bears climb trees, raid squirrel caches, and compete directly with human harvesters. When the pine nut crop fails, and it does, because good harvests come only once every 4 years, the bears don't just go hungry, they come to town. In the Irkutsk region, poor pine nut years have driven bears into residential areas. The same dynamic plays out in North America, where grizzlies depend on white bark pine, a species now threatened by climate change. In 2009, more than 3,000 people in France reported a bizarre symptom, a constant, bitter, metallic taste that lasted for days, sometimes weeks. It was called pine mouth syndrome. And when scientists analyzed every single case, they found the same species every time: Pinus armandii, the Chinese white pine. Not one case was caused by Siberian pine nuts. Pinus armandii is not recognized as edible by the FAO, but it's cheaper to harvest, and it looks similar enough to fool consumers. Pine nuts are now among the top 10 most vulnerable foods for economic adulteration worldwide. The fraud is detectable. Fatty acid fingerprinting, DNA analysis, infrared spectroscopy, all can distinguish species with over 95% accuracy. The technology exists. The enforcement doesn't. Inside every Siberian pine nut is a molecule called pinolenic acid. It makes up 14 to 19% of the oil, and it's found almost nowhere else in nature. Its 3 double bonds are arranged in a pattern that doesn't exist in any other common food. What makes it extraordinary is what it does when it reaches your gut. It activates 2 receptors simultaneously, FFA1 and FFA4. These are the same receptors that pharmaceutical companies have spent billions trying to target with synthetic drugs. In 2023, a drug called Ozempic became the most talked about medication in the world. Its active ingredient, semaglutide, causes dramatic weight loss by mimicking a hormone called GLP-1. It costs up to $1,349 a month in the United States. It requires a prescription and a weekly injection, and it causes nausea in 44% of users. In 2008, a clinical trial in the Netherlands gave overweight women 3 grams of pine nut oil. Within 30 minutes, their levels of CCK, a satiety hormone, rose by 60%. GLP-1, the exact same hormone targeted by Ozempic, rose by 25%. Their desire to eat dropped by 29%. The effects lasted 4 hours. Side effects reported: 0. Let's be clear. Pine nut oil is not a replacement for Ozempic. Semaglutide produces 15% body weight loss that pine nut oil cannot match, but they share a fundamental mechanism. One costs $1,000 a month and requires a prescription. The other costs $30 and sits on a shelf. One replaces your body's system. The other activates it. The question isn't which is better. It's why we are not studying both. Here's what happens inside your body. Pine nut oil arrives in your small intestine. Enzymes slowly release pinolenic acid from its triglyceride packaging. This takes hours, not minutes. Each wave of pinolinic acid contacts specialized cells called L cells, triggering a cascade: receptor binding, calcium flooding, hormone release. GLP-1 is secreted toward nerve endings in the gut wall. Those nerve endings belong to the vagus nerve, the longest nerve in your body, running from your gut to your brain. The signal races upward to the brainstem, then to the hypothalamus, your appetite control center. Neurons that say stop eating are activated. Neurons that say keep eating are silenced. You feel full. And here's the crucial difference from Ozempic. This GLP-1 acts locally, on nerve endings in your gut wall, and is destroyed within 90 seconds. It never reaches your brain's nausea center. Semaglutide is engineered to last a week, flood your entire body, and cross into your brain, which is why nearly half of users feel sick. In 1995, at the Tomsk Scientific Research Institute of Balneotherapy, 4 Russian doctors gave 30 patients with stomach ulcers a teaspoon of pine nut oil 3 times a day. After 20 days, every single patient was free of pain. 10 had complete endoscopic healing. The ulcers were gone. Duodenal reflux was cut in half. Gallbladder secretion doubled. It was an open-label study, no placebo control, so it wouldn't meet today's gold standard. But the results were striking enough that the protocol is still used in Russian clinical practice 3 decades later. There's a theory in biology called xenohormesis. When plants are stressed by cold, drought, UV radiation, they produce defensive compounds. And when animals eat those stressed plants, those compounds activate the animal's own stress response pathways, longevity pathways, repair pathways. Siberian pine trees survive at minus 60 degrees Celsius. They endure 6 months of darkness. The phytochemicals they produce under that stress may be more potent than those from any cultivated crop, wild harvested from the coldest forests on the planet. That's biological terroir. The global pine nut market is worth $3.67 billion and growing at 8% per year. Russia exported 9,500 tons in 2023. China buys 81% of it. New export duties are designed to keep more value in Russia, but the fundamental tension remains. These nuts are wild harvested from ancient forests. You can't farm a 1,000-year-old ecosystem. Aspirin came from willow bark. Metformin came from a flower. The most important cancer drug of the 20th century came from the bark of a Pacific yew tree. Every one of these breakthroughs started with a natural compound that someone decided to study seriously. Pinolinic acid activates the same pathway as a $100 billion drug class. But a proper phase 3 trial costs tens of millions of dollars, and you can't patent a molecule that grows on trees. So the research stalls. In Russian, pine resin is called zhivitsa, from the word zhivoy, meaning alive. It's the tree's living blood. For centuries, Siberians have used it to heal wounds, fight infections, and cleanse the body. It destroys pathogenic bacteria while leaving beneficial microflora intact. The tree heals itself, and it heals us. The oldest recorded Siberian pine lived for over 1,000 years, and it was still producing seeds. A single tree, feeding nutcrackers, bears, squirrels, and humans across 40 generations, wild harvested, unfarmed, unpatented. A molecule that activates your body's own satiety system, wrapped in a shell that a bird carries across the forest floor. We have the science. We have the trees. The question is whether we have the wisdom to protect both.